We can define the reaction rate as follows. V, the rate of a reaction, okay, is 1 over R, where R is the coefficient of reactant R, okay, so times the rate of consumption of reactant R. So, for example, let's say your reaction is 2A plus B gives you 3C. Then we say that the rate of reaction is equal to 1/2 of the rate of consumption of A. Okay? Or you can say that the rate of consumption of A is 2 times what we call the rate of the reaction. Why do we have to define the rate of reaction this way? Because let's look at this balance equation right here. Every time I lose 2 moles of A, I'm going to lose a mole of B, right? So if I'm losing 2 moles of A per liter per minute, then I'd only be losing 1 mole of B per liter per minute. So if I tell you what the rate of the reaction is, I have to tell you, am I referring to A or am I referring to B? I can't just say moles per liter per minute. So to avoid ambiguity, we define it so that if you don't specify A or B, then we assume that whatever it is you're quoting would be whatever the rate for A is or for B is, you divide it by the coefficient of A or B in the balance equation. Because 2 moles per liter per second for A, you divide that by 2, that gives you 1, right? Whereas 1 mole per liter per minute for B divided by 1, that will still give you 1. So that would correspond to the same rate of reaction. Okay, so for example, let's look at this question right here. Suppose rate is A is being consumed at a rate of 4.4 moles per liter per minute. What's the reaction rate? V would be equal to 1 over the coefficient of A is 2, right? Times the rate of consumption of A. So I'm just going to call that V sub A. Okay, so that's 1/2, and that's going to be negative delta A over delta T. Okay, the rate of consumption of A. And the 2 here is the coefficient of A in the balance equation. So that's equal to 1/2 of 0.40 moles per liter per minute. So we say the rate of the reaction is 0.20 moles per liter per minute. Okay, so to avoid ambiguity, when we simply say the rate of reaction, then you multiply that by the coefficient to get the actual rate of consumption of a reactant. Same thing with the product, rate of production of product. You divide that by the coefficient, that will give you the rate of reaction. Let's look at an example here. If the rate of reaction is V, what is the rate of production of C? Is it V, 2V, or 3V? Ready? Let's see if you got that concept. Okay. 3V. Very good. Okay. So we say that the rate of consumption of A is equal to 2V. Okay. The rate of consumption of B is what? It's just V. The rate of consumption of C is 3V. Okay. So rate of consumption of A is negative dA dt. The rate of consumption of B is negative dB dt. And the rate of production of C, that's just positive dC dt. Okay. When we're dealing with products, the rate of production would be a positive of the derivative. This would be negative for rate of consumption. Okay. Here's another clicker question. Let's say you have a reaction 2A plus B gives you 3C. The rate of reaction is 0.3 moles per liter per minute. What's the rate of production of C? Ready? Is it 0.1 or 0.9? Okay, 0.9. Very good. because you say rate of production of C, which is dC dt, is equal to 3 times the rate of the reaction. The coefficient of C is 3, so 3 times 0.30 moles per liter per minute, or 0.9. Okay? Okay, let's try another one. Same reaction, same rate, 0.4 moles per liter per minute. At what rate is B being consumed? What is V sub B? Rate of consumption of B. Is it 0.2 or 0.8? This is negative dV dt. That's equal to, oops, oh, 50-50. Okay, give you a chance to fix your answer. You need to convince your neighbor your answer is correct first. Who picked A and who picked B? Yeah. What was the relationship? V sub B is equal to 2 times V, right? Remember? V sub C is 3 times V. V sub A is V. Oh, it's a different one. So let's do it over. What would it be? Oh, I'm sorry. This is not the rate of reaction. I'm sorry. Sorry. This is the rate of consumption of A. My mistake. All right. You're given that V sub A is 0.4 moles per liter per minute. I'm not reading my question right. What is V sub B? Okay. Sometimes I'm not paying attention. Huh? So, made a mistake on that one. I didn't read my question right. So if the rate of consumption of A is 0.4, what's the rate of consumption of B? According to my balance equation, every time I lose 2 moles of A, I'm going to lose a mole of B, right? So which one will be going faster, A or B? Okay. So if my A is being consumed at a rate of 0.4 moles per liter per minute, how much is my B? How fast is my B being consumed? Answer is A. Very good. Okay. So V sub B would just be. So we say that V sub A is equal to 2V, right? So your rate of reaction is equal to V sub A over 2. So that's going to be 0.40 moles per liter per minute divided by 2. So your rate of reaction is 0.20 moles per liter per minute. Your rate of consumption of B would just be equal to V, which is going to be 0.20 moles per liter per minute. As expected, B is going to be lost at a slower rate than A, because every time you lose 2 moles of A, you only lose a mole of B.